Hey guys, welcome back. For this video, we're going to talk about representing relations, which is lesson 3.1. If you look on the side here, we got today's goals. This is actually going to be a two-day video, two-day lesson. The first one here, we are going to represent relations and interpret graphs. The second part right here we'll do on the next video. We will discuss what a relation, domain, and range mapping are, and we're also going to do independent and dependent variable. Some of you are already probably familiar with that. The one big thing you want to take away from what relation is anytime you take numbers and pair them together, at least in mathematics. So you see we have a couple of sets. If I take any of those numbers, let's say I take the 3 and I pair it with the 40, this grouping right here is then referred to as a relation. Now we are used to seeing it written like this as an ordered pair, and that is one way of describing a relation. The number that we choose on the left-hand side here, we refer to that as the domain. We're also going to call that our independent variable because usually that's the number we choose, we make up. Sometimes it's given to us, but most of the time we make it up ourselves. And the one thing that we can't make up is the range, which is this number on the right-hand side. There's usually some sort of rule that changes the domain into the range, and the range is almost always calculated. A relation can be represented in multiple ways. A mapping is just one of those ways. So if you look at the pairs down here, 3, 5, -4, -2, 0, and 2, one way we can represent them is in a mapping, which looks like this, where we take all the domain numbers, which is, again, the numbers on the left-hand side, and we put them on the left-hand side of our screen as well, and we just put a little box around them. We put all the range values on the right-hand side, put a little box around them, and we use a little arrow to show how they're connected. What number maps to another number? So in other words, what's the relation between them? So here we have the 3 mapping to the 5. We could also put them in a table format. Looks like this, and some of you have probably seen this before. And instead of just using the words domain range, at the top we use X and Y, which is a lot like our ordered pair that you saw earlier. We're used to seeing that in XY format. Something else you'll notice about the table is the 3 is still paired up with the 5, showing the same relation. Same as the -4, the -2, and the 0 and the 2. On a graph, we can represent the relation as well. So if we look at this point right here, this one is 1, 2, 3 to the right on X. So 3 to the right on X. And 1, 2, 3, 4, 5 up on Y. 3, 5, which is, again, our very first point that we had up here. The last way we represent a relation is with an equation. And you'll see this letter out here by itself. When the letter out here by itself, that's almost always the dependent variable or output variable or range value. Remember, in this context, we can select anything we want for the input, which is X, or the domain, or the independent variable. And then there's some rule that controls what the output becomes. That's why we don't choose our output or our range values. We choose our inputs and let the equation tell us how the output's supposed to be. Example 1, we want to represent a relation in a table. So we want to create our table first. In our table, we want to put our first point, which is 2, 0. Again, 2 is the X or the domain value, so that goes first. And the 0 is the range value, the Y value. 0, 4. 0 is our domain. 4 is our range. 3, -5. 3 is our domain. -5 is our range. -3, -5. -3, -5. -3 is our domain. -5 is our range. Typically, I like to put these in order from top to bottom, smallest to biggest, which means if I put the 2 down here, that means the 0 would have to follow it down here because those two are paired together as a relation. We can also put these on a graph. We had the ordered pair of 2, 0. So 2, 0. We go to the right 2, but we don't go up or down on the y-axis. Remember, this is X, this is Y. We also had 0, 4. So 0 is no X change, no left or right. Up 4, 1, 2, 3, 4 would be right here. Then we had 3, -5. So 3 to the right, 1, 2, 3, and down 1, 2, 3, 4, 5 would be down here. and then -3, -5. So again, this is the x value, this is the y value. So left 3, because negative is to the left of center, and down 5. So 1, 2, 3, 1, 2, 3, 4, 5 would be down here. When we go to do a mapping, I like to put these in order again. I didn't do it in the table, so I am going to do it in a mapping. So my smallest domain value was -3. Then my next smallest was 0. Then my next smallest was 2. And then finally at the largest one I had a 3. Now on the right hand side, and this is going to be called our domain. I'm going to put a little box around it. Now I got to put our range values in there, smallest to largest. I had a -5. Now here's one of the unique things about mappings. We had a -5 twice, but we're only going to show it once because we're going to map the domain to the -5 twice. And I'll show you what that looks like. So we're going to write the -5 once. The next smallest number was a 0, so I only had 3 different domain values. And then 4, and this is our range. And then we look back, go, well, -3 was mapped to -5, so I'm going to draw an arrow across like this. The 0 was mapped to a 4, so I'm going to draw an arrow like that. The 2 was mapped to a 0, so I'm going to draw an arrow like this. And the +3 was also mapped to a -5, so I'm going to draw an arrow like this. And that's where we have our 2 different ordered pairs with the same y value, or the same range value. Part B, determine the domain and the range of the relation. Well, again, the domain is just the x values, the input values, the numbers on the left, and the range was the y values, the numbers on the right. Go ahead and pause the video and attempt to check. Okay, so this one's asking us to list the ordered pairs in each relation. We have 3 different ways of expressing it. We got a table, a graph, and a mapping. So looking at the table, the relation would be domain, range, so that would be -1, -5, and I'm going to put them in the ordered pair format. Then I had a 4 and a 7. Then I had a -2 and a 3. And notice how our ordered pairs are in the same order, x, y, as our table. Domain is on the left, range is on the right. From the graph, I'm going to go from left to right, which means I'm going to start with this point on the left, which would be -2. So it's left 2, and then down 1, 2, 3, 4, so -4. So my first point there would be -2, -4. I'll go to this point for next one, so it would be left 1, which is -1 for the x or domain, and up 1, 2, 3, so +3, so left 1, up 3. My last point out here is to the right, 1, 2, 3, 4, 5, so +5, and it's up 1 from there, so that's +1. For our mapping, we're going to start with the domain side, which is our x side, which is 1, so put a 1 in. And it maps to a 5, so that's a 1-5 pairing or relation. Then I have a 5 that goes to a -1, so 5 to -1. And our last point there is a -6 to -1. And it's okay for the range values here to be repeated. That's normal. For the second part of our lesson, we're going to learn how to analyze graphs and relations. So in this example, we have total time driven during your course can help you visualize the progress. A relation can be graphed without a scale on either axis to show the relationship between the independent and dependent variables. These graphs can be interpreted by analyzing their shapes. So independent is the input, we usually call that the x, and the dependent is the output, which we refer to as the range. Often we use that with y. So this one we have a input value of days going in this direction. So that's our independent. And we have an output of driving time going in this direction. And that would be our range or dependent variables. Example 2. The graph represents the number of texts sent by Nora throughout the day. Identify the independent and dependent variables of the relation. Based on the way that the table is laid out, our independent is going to be our y value. It's going to be this value going this way, which is going to be our time. And to give you a little hint here, most of the time, whenever you have a time value involved in your graph, it's almost always the input or the independent variable, the domain or the X value. The dependent variable then would be the one that's going up this way, because text messages sent does depend on amount of time. If no time passes, then no text messages can be sent. So for our dependent variable, we have text messages sent. Part B, describe what happens in the graph. As you move from left to right along the graph, time increases and the number of text messages sent increases until the graph becomes a horizontal line. The horizontal line means that time is increasing, but the number of text messages sent remains constant. During this time, Nora stopped sending messages. Then she continued to send text messages until she stopped again for a period of time. Finally, Nora began sending text messages again. Go ahead and pause the video and attempt the check. Okay, let's identify the independent and dependent variables of each relation. The average price of a ticket to an amusement park has steadily increased over time. Well, again, when we have time involved, it's almost always our independent variable. So the average price of a ticket is the dependent variable. Time is the independent. So again, dependent is like your range or your Y value. And independent is your domain or your X values. The air pressure inside a soccer ball decreases with time. The time is the independent variable. Air pressure is the dependent variable. So the amount of air pressure depends on how long time has been passing. Go ahead and pause the video and attempt the check. Okay, so for this example, for this check, after an airplane takes off, its altitude increases rapidly. That's an important term there, important word. Once it reaches a desired altitude, it flies, continues to fly at a level for a short period of time. Okay, so it's going level. The plane's altitude fluctuates slightly due to turbulence. So fluctuates slightly due to turbulence. Finally, the altitude decreases quickly as the plane lands. Which graph best represents the situation? Now, the first one is increasing rapidly. So if we look at all the graphs, they all appear to be increasing rapidly except for C. They also decrease rapidly. Well, they all appear to decrease rapidly as well. So that doesn't help us. The middle section where it says that it flies level for a while, but some of its altitude changes or fluctuates due to turbulence, but it says it fluctuates slightly. There's no fluctuation in A. D has what appears to be significant amount of fluctuation very rapidly. So by default, B has to be our final answer. For the next part of our check, Kane notices the traffic congestion on his street on weekday mornings depends on the time of day. So traffic congestion is the dependent, depends on the time, independent, input, output. He draws a graph to represent the relationship between time of day and the volume of traffic congestion on a street. Analyze the orange segment, select the statement that best describes what's happening during this time. If we look at the graph, time is progressing forward, but the amount of traffic congestion is going down. But it's going down, see, in a straight line here. So that would be a steady rate. So it is not increasing. It's not constant because it's going down. Constant, not constant here. Constant would be flat like a horizontal line right here and here. So traffic congestion is decreasing at a steady rate. So the choice here is D.